Welcome back, students, to this video on equilibrium. All right, this is going to be a super graph. I'm going to combine figures 4.1, 4.2, 4.3, and 4.4 together, okay? Now, I'm not going to put it on the whiteboard, but so pay attention. I'm going to tell you what each of them are going to do. 4.1 tells you about just the concept of equilibrium. So it's just going to draw the intersection of demand and supply, and at that intersection is our market equilibrium. And then 4.2 is going to talk about the horizontal reading of equilibrium, in which we're going to find out how prices are discovered, okay? And then 4.3 is going to be about the vertical reading of equilibrium, and that is going to describe what happens when we have too much or too little quantity. So if you really want to understand equilibrium, you want to think of balance, okay? In physics, equilibrium is a state of rest, okay? And so once we reach this equilibrium, it's going to stay there. It's something that's gravitated towards until something else changes, okay? We'll get more into that later. And then for a concept, another thing to keep in mind is equilibrium, okay? So some things are going to be equal here that I want you to pay attention to. So think of Goldilocks and the three bears. So at equilibrium, the price is not too high, it's not too low, it is just right. And in the quantity side, the quantity is not too low, it's not too high, it is just right, okay? And so this point right here is the equilibrium in which you guys are going to be seeking out, but you are doing this in the dark, okay? And so what you're going to see is, we see this, but what we don't see are the demand and supply curves that are shown in these figures. So it's very important to understand that equilibrium is a way of modeling a price discovery process, okay? All right, so concept, equilibrium, state of rest, as I point out. But at this equilibrium, once we reach it, things are actually equal, okay? So what we can do here is we can label this at PE, okay, and that's going to be equal to 30. Quantity demanded equals quantity supplied, and that is equal to 65, okay? And so this right here is your equilibrium price, and this right here is your equilibrium quantity. So this E subscript just stands for equilibrium. All right, so when the price is 30, the amount that consumers want to buy at this price equals the amount that sellers want to sell at this price, which is 65 million barrels of oil per day, okay? So you'll notice here I got a couple things being mapped on this graph here. So remember, everything in dollar terms goes on the vertical axis, everything in quantity terms goes on the horizontal axis, okay? And so that includes the price, which is all we're seeing right now, the value, which is shown as the y-coordinate of the demand curve, and the cost, which is the y-coordinate of the supply curve. We covered this in chapter 3, okay? If you need a review, go back to the previous videos. All right, so that's one side of equilibrium, okay? So that's like a horizontal interpretation of equilibrium, because we're looking at that price, and we're seeing that the quantity demanded equals the quantity supplied, okay? We'll get back to that in a second. We're just focusing on the concept. And if we look at it on the quantity side, we could say at QE equal to the 65 millionth barrel of oil that day, the value of the last buyer consuming that oil is equal to the cost of the last producer extracting that oil, and guess what? It's equal to $30. Okay. So if we were to take the 65 millionth barrel of oil per day, we could say that the value and the cost is equal to 30 at that equilibrium price. So equilibrium is a thing that we want to talk about there, okay? So think of equilibrium in terms of physics, something that we're going to gravitate towards something that we're going to eventually discover. We call it actually emergent order, in a sense. We call it Adam Smith's invisible hand, okay? I mean, you can't really see it happening. It is also guiding the self-interest of buyers with the self-interest of sellers to promote the social interest, which is maximizing the gains from trade. This is what is covered in figure 4.4, okay? All right, so now we've got our concept here, okay? I may add some more stuff in here as we go through, but I want to bring your attention to our equilibrium table. Well, our equilibrium table is simply a combine of the demand table and the supply table. So you're seeing the quantity demanded and quantity supplied at each price. Okay, so now we can start our story of Goldilocks and the Three Bears. All right, so what happens if we don't know this price? We don't know what the demand and supply curve look like. Well, we just have to guess. It's trial and error. And so if we're Goldilocks and we're guessing that the price is too high, well, here's what's going to happen. If we just look at quantities demanded, it's going to be here, okay? And now I'm going to draw on the demand curves and supply curves to make it a little bit easier to see. So I'm going to try to make it a relatively straight demand curve. So let's do that. Yeah, close enough. Okay, we don't even need to go to the axis there. We can choose to go to axis here. Okay. And so we're going to label this demand. And it's the demand for oil today. Okay. And then we're going to do the same thing with supply. We're going to connect these dots here. Come out a little bit. Let's even go all the way to the origin here. Okay, makes the math nice and easy if you want to actually calculate consumer surplus and producer surplus. Okay, there is our equilibrium. Okay, we see this eventually, but first we got to guess. We got to discover this equilibrium. And so in this case, Goldilocks thought the porridge was too hot. Okay, and so buyers don't like high prices. They're not willing and able to buy as much. And so when you hit that demand curve, again, what we're doing here is this is figure 4.2. We're doing the horizontal reading of the demand of the equilibrium here. Okay, and so this becomes our quantity demanded at a price equal to 50. Okay, all right. So we're going to reuse that line just to make it less messy. In fact, I ended up modifying some of the data, like these 2 points right here, to make this a lot cleaner, okay? Doesn't change the concept, just makes it easier to draw. Okay, follow that $50 price line. A price of $50 per barrel, the most that sellers are willing and able to produce is going to be much higher. Remember, sellers like higher prices because now they can cover higher cost forms of oil extraction. So I'm going to go through this doc, so I'm going to reuse it. And we could say that this is the quantity supplied at, which is 95 million barrels per day, is the quantity supplied at P equals 50. So when the price is too high, more sellers want to sell at this price than buyers want to buy at this price. And we call this horizontal distance a surplus in quantity. So economists are very efficient. We like to use the same word for multiple meanings. And so this surplus is not a surplus in the dollar terms when we covered consumer surplus, producer surplus. It's a surplus in quantity. Okay. All right, so what's going to happen is how do we get from here to the equilibrium? Well, you might think, well, this is just a tug of war between buyers and sellers, but it's actually sellers that are going to compete here, okay? And this is where I'm going to put the concept. So if the price is above the equilibrium price, then sellers compete and the price goes down. Okay, so what's going to happen is we're going to gravitate towards 30. So suppliers start to undercut each other's prices. There are some suppliers that just can't extract oil at that low of a price. They withdraw from the market. Then there are new consumers that come into the market as the price falls. And as this is happening, the horizontal distance is shrinking until we reach that equilibrium where the quantity demanded equals the quantity supplied. And this is occurring at $30. Okay. All right, so we know that's the price here. Okay. All right, so since I mentioned that, I'm going to go ahead and actually I'll save it. Let's wait. All right, so Goldilocks guessed too high. What if she guessed too low? What if she thought the price was only $15? Well, we take that same $15 and we follow the $15 per barrel. And first thing we're going to hit is the supply curve. And so now 32 is the quantity supplied at a price of $15. And so the price in this case is really low. And so only the lowest cost producers can produce this unit. Okay? All right, next up, we've got the quantity demanded. So we keep following this price line to see how much consumers want to buy. When we hit the demand curve, we get the quantity demanded at a price of 15. And that's 95 million barrels of oil, okay? So what's going to happen is we do the horizontal distance. We're going to have more buyers who want to buy at this price than sellers who want to sell at this price. And so we would have a shortage of 63 million barrels of oil per day. That's huge, okay? So this is a shortage in quantity. Okay, so one of the big ideas here is that now buyers are going to compete with each other. They're going to be jumping at the bit to find sellers, okay? And that is going to put upward pressure on the prices. Buyers will express willingness and ability to pay a higher price, and this will enter higher cost production methods of oil. And so what's going to happen is as the price rises, quantity demanded decreases, quantity supplied increases, shortage is shrinking, 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 gone. Okay? And so the other big idea, when the price is less than the equilibrium price, then buyers compete. And the price goes up. Okay? And what that means, that when the price is equal to the equilibrium price, no shortage or surplus. So when we reach this $30 price, the equilibrium price, it hits the demand curve and the supply curve at the same point at 65 million barrels of oil. And so quantity demanded equals quantity supplied, no shortage, no surplus. Okay, so we've gone all the way through figure 4.1, 4.2, which is the horizontal reading of the equilibrium, which is what we just covered, that price discovery process. Now, why should we care is what about 4.3 and 4.4 are figuring about. Okay, so a lot of people just take price discovery for granted, okay? But a lot of people don't take well-being for granted, and that is what we're going to talk about next, okay? So now Goldilocks is trying to guess the just right quantity because we're going to do a vertical reading of the equilibrium where we start on the x-axis and read up to the respective curves, okay? So what happens if Goldilocks produces too little? If Goldilocks produces too little, 32 million barrels of oil per day are brought to market. And what happens is that at 32 barrels of oil per million barrels of oil per day, the lowest price that sellers are willing to accept is $15. But because oil is scarce, the highest value users end up competing the limited quantity away from these lower value uses here. So only these high value users buy the product, okay? And they have a willingness to pay or a value of $50. Okay, and so what happens is the value of the last unit traded, the 32 millionth barrel of oil, is much greater than the willingness to accept, which is $15 per barrel. So we are leaving money on the table, opportunities for gains from trade, okay? Because all of these buyers have a higher value than all the cost of all these sellers. And so there are gains from trade here that we're not realizing, okay? All right, so Goldilocks produced too little. Next period, she produces too much. So in that case, she makes 95 million barrels of oil per day. There's a glut of oil, okay? And in this situation, we take that 95, we go up vertically till we hit the demand curve. And the most that all the buyers combined are willing and able to pay is $15 per barrel. Now there's some that have higher values, but because of competition and the fact that there's relatively a large amount of oil, they don't have to compete as much to get oil, and so the price goes low, okay? And so, but the cost is high, it's real high, and so what's going up here is we got at 95 million barrels of oil per day, the 95th millionth barrel of oil produced that day costs $50 per barrel. And so we are using $50 of resources to create $15 of value for that last barrel of oil. And for all these units beyond the equilibrium, we are doing is what we're calling wasting resources, okay? All right, so the big challenge is, how do we see this on the graph? Okay, so the main concept is, if we produce too little, we have unrealized gains from trade. If we produce too much, we're going to waste resources. So only that Goldilocks amount, that equilibrium quantity, is going to maximize the gains from trade without wasting resources. So we can measure this actual well-being by looking at the areas of the graph here. And so I'm going to label them as such. I for this triangle, and then we've got I for this square, I for this triangle, IV for this triangle, okay? All right, bear with me, we're still going here. Then we've got V for this rectangle. Then we've got VI for this triangle. And then VII for this triangle here, okay? So I, IV, V, VI, VII. Why am I using Roman numerals? Because we're already using numbers for the prices and quantities here, okay? So it's just to kind of differentiate. All right, so let's talk about the gains from trade and the losses from trade as we do this. Okay, so if we produce too much, those wasted resources can be represented by just one area. And that is equal to IV. Okay? All right. If we produced just the right amount, then we wouldn't have any wasted resources. If we produce too little, we're going to have unrealized gains from trade. Unrealized gains from trade, money left on the table, okay? And that would be equal, just put it down here, equal to I plus VI. Okay, so this combined triangle here would be unrealized gains from trade, okay? Now, both the wasted resources triangle and the unrealized gains from trade triangle are considered what we call dead weight loss triangles, or DWL for short. And that means that we are either leaving money on the table that no one gets, or we're taking money off of other tables because we have limited resources and unlimited wants. So if we're overproducing here, we're underproducing somewhere else. So in some other market that we're not seeing here, we have underproduction. because of these wasted resources, because those resources are more valuable somewhere else because the cost is greater than the value in that sense, okay? All right, now let's talk about the just right quantity, okay? So just going to draw a line here and then just kind of say at QE, the just right quantity, the Goldilocks just right quantity here, we are going to have the consumer surplus and the producer surplus and we're going to add them together, and that's going to give us the market surplus, which is gains from trade. So right here, these are deadweight losses, and gains from trade is also known as market surplus. All right. Now, what is consumer surplus? Well, it is the area underneath the demand curve which represents each consumer's value, that y coordinate of the demand curve, above the price they actually pay at equilibrium. It's $30. So all these buyers are getting gains from trade, and if we approximate all of those gains from trade for all the buyers in the market, up here is buyers, down here are non-buyers because the price is greater than their value, okay? If we add I plus I plus III, we get consumer surplus. The buyers gains from trade. Okay, so II plus III, okay? So all the individual consumer surpluses added together, okay? All right, now, next up, we've got the producer surplus. Well, the producer surplus means that any surplus money you have left over from your revenue after paying for your costs. And the costs are represented by the y-coordinate of the supply curve, okay? So because at equilibrium 65 million barrels of oil per sold, that means that all of these low-cost sellers are the sellers and all the high-cost producers are non-sellers, okay? And so that would be the area above the supply curve, underneath the price sellers are receiving, and to the left of the quantity sold. Okay, so that would be V plus VI plus VII. Okay, so we add all those together, we get our market surplus, which is I plus II plus III plus V plus VI plus VII. Okay, so society is better off. In this case, it just represents the buyers and sellers of the market by the area of this large triangle here, and that is the gains from trade. And so the gains from trade are maximized. So our gains from trade are maximized. Boom. All right, so what's happening here? Well, we worked with a situation where we had almost no information. All we knew is that buyers had their own values for consuming oil and sellers had their own costs for consuming oil. And we knew that if the price was too high, sellers would compete and bid the price down. And if the price was too low, buyers would compete and bid the price up, and they would discover the price. And not only would they discover price, that would result in a non-shortage and a non-surplus in quantity such that the gains from trade are maximized. And so even though buyers only care about their own well-being and sellers only care about their own well-being, society is made better off through this free market competitive institution. All right, so I hope you enjoyed this video. and I'll see you at the next one.